2.5 is division properties of exponents. Now we did multiplication of powers, right? Multiplication of powers, where we added exponents. What do you think is going to happen here when we're dividing powers? Subtract. We're going to subtract. Very good. And then we're going to look. So that's just our guess is what's going to happen, and we're just going to prove to see what happens over here. Okay. So we have 2 to the 6th divided by 2 squared. So if I expand this out, we've got 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Okay? And then in the denominator, we have 2 times 2. 2 squared. Now what happens when you have a factor on the top and the same factor in the denominator? What can I do? You can cancel them out, right? So here I'm going to cancel out 2 and 2. That is equal to 1. So it doesn't change anything when we cancel it out, right? So 2 and 2. I'm going to cancel that out. Can I cancel anything else out? No. So if I want to write this, 2 times 2 times 2 times 2, that's going to be 2 to the 4th power. So, observe. How do I get from here to there? You subtract, just like what we thought. Very good. So here is your rule. To divide powers with the same base, you want to subtract the exponents. And of course, here are the examples here with how I want you to show your work. You do not have to multiply those things out anymore or expand those things out anymore. Because we figured out that you need to subtract the exponents, this is how you're going to show your work. Okay? So here you have 2 to the, oh, this is the one that we did. You have 2 to the 6 minus 2. And then over here, we have x to the 4th over x to the 7th. So we have x to the 4 minus 7, but that then gives us a negative exponent, right? So x to the negative 3rd, then, to simplify, must be flipped in order to make that exponent positive. So problem 1 is dividing algebraic expressions. So we're just going to do exactly what we just learned. We subtract our exponents. For a, y to the 5th over y to the 4th. We show our work by subtracting the exponents, y to the 5 minus 4, which is equal to y to the 1st. Do I have to write the 1? No. Do I want you to write the 1? No. Okay. Are you going to write the 1 just because you want to? No. No. Okay. For letter B, we have d to the 3 minus 9, which is equal to d to the negative 6. And then the negative exponent needs to be flipped. So this is going to be 1 over d to the 6th power. So now we have some more involved algebraic expressions. But you are still only going to be able to subtract the exponents when you have the same base. Okay? So, we're going to deal with the k to the 6th and the k. And we will deal with the j squared and the j to the 5th. So, when we simplify this, we're going to do the k's first. So, k to the 6 minus 1 and j to the 2 minus 5. Okay? So, when we simplify, we get k to the 5th, j to the negative 3rd. And of course here, the only thing that needs to flip is which one? Just the j, right? That one just comes down to the denominator. So we end up with k to the 5th over j to the 3rd. We'll go back to D if we have time at the end. So here we have x to the fourth, y to the negative first, z to the 8th, over x to the fourth, y to the negative fifth, z. Okay? And again, we're only going to subtract the exponents if they have like bases. So we're going to do the x's, then the y's, then the z's. And if you want to highlight them, you want me to highlight them, there are the x's, there are the y's, and there's the z's. Okay? So we've got x, this is equal to x to the 4 minus 4, y to the negative 1, right, it's going to be plus because it's minus a negative 5. Very good. And then z to the 8 minus 1. So just like you said, this is going to become plus. But I still want you to write minus in there, okay? I want you to write minus the negative. Okay. So we end up with x to the 0, y to the 4th, and z to the 7th. And of course, anything raised to the 0 power is equal to what? 1. Good. So that's equal to 1. So we end up with y to the 4th, z to the 7th. And you're done. Problem 2. It is dividing numbers in scientific notation. You can use the property of dividing powers with the same base to divide numbers in scientific notation. It says during 1 year, and yes, you should write this down, Honduras had a population of 7.33 times 10 to the 6th people. The area of Honduras is 4.33 times 10 to the 4th miles squared. What was the population density of Honduras that year? So we want to know how many people are in every square mile of Honduras. So that's our ratio. People to square mile. Okay? So now all we have to do is substitute into our ratio. So the number of people, 7.33 times 10 to the 6th. The square miles, or the area, is 4.33 times 10 to the 4th. And now we can divide. We're going to divide our first factors, and we will divide our second factors. Okay? So we've got 1.69 times 10. What do I do to the exponents? You subtract them. So 6 minus 4. I'm just going to write 6 minus 4, show the word. So we have 1.69 times 10 squared. What are my units? People per square mile. Very good. So our units, people per square mile. So you can use repeated multiplication to simplify a quotient raised to a power. Now yesterday we had a power raised to a power, a product raised to a power. Today we have a quotient raised to a power. What did we do yesterday when we had a product raised to a power? What do you mean? The exponent got applied to everything inside, right? So if I had AB squared, that 2 is going to go to the A and the B, right? So we ended up with A squared, B squared. So what do you think is going to happen here? It's going to get applied to everything inside the parentheses, right? So here, this exponent is going to go to that x, and it's going to go to that y. So we will end up with x to the third over y to the third.
That's the problem.
All right, so for this one, we are going to apply the 3 to the numerator and to the denominator. So we will end up with 3 cubed over 5 cubed. Okay, and if they ask you to simplify, of course, we will multiply it out. So 3 times 3 is 9 times 3 is 27, right? Over 5 times 5 is 25. 125? Very good. Problem 3 is raising a quotient to a power. We want to know what is the simplified form of 4 over x cubed raised to the second power. So we have 4 x cubed squared. And I just rewrote it, that's all. All right. And now the exponent gets applied to everything inside the parentheses. So we have 4 squared over x cubed squared. Right? And now you can simplify. So 4 squared, of course, is 16. And x cubed to the second power, what do I do to those power raised to a power? You multiply. Very good. So this is going to be x to the 6th, and there's your final answer. All right, so describe 2 different ways to simplify the expression a to the 7th over 5 quantity cubed. Okay? What do you think? What can I do? Okay, so yep, we can apply the exponent. So we have a to the 7th over a to the 5th quantity cubed. And like you said, we can apply the exponent to everything inside. So we will end up with a to the 7th cubed over a to the 5th cubed. And then we can simplify that. So that's going to be a to the 21st over a to the 15th. And then we have a power divided by a power. And what do I do with that? Subtract. So this is going to be a to the 21 minus 15, which is a to the 6. Okay? So, yeah, we can subtract here. So, we can get a to the 7 minus 5 to the third power, which gives us a squared to the third power. And now I have a power raised to a power. What am I going to do with that? You multiply the exponents. So that's going to be a to the 6th power.
Awesome.
You can write an expression in the form a over b quantity to the negative n using positive exponents. And again, let's go with applying the exponent to everything in the parentheses. Okay? So here we're going to apply the negative n to everything inside the parentheses. Okay? So this, we end up with a to the negative n over b to the negative n. When we have negative exponents, we just flip it. So here, this a to the negative n, that's going to go down to the denominator. And this b can go up is going to go up to the numerator. So we end up with b to the n over a to the n. So what do you think you can do when you have a over b all raised to the negative n? You just flip it. Okay? All right, problem 4 is simplifying an exponential expression. We want to know what is a simplified form, and I need to rewrite this bigger. We have a over 5b raised to the negative 2. Here, all you have to do is flip the numerator and denominator, right? So we end up with 5b over a, and now this is going to be all to the positive 2, right? We still need to simplify, so that 2 needs to get applied to everything inside the parentheses. So the 2 goes to the b, the 5, and the a. So we end up with 5 squared, b squared, over a squared, which of course simplifies to 25 b squared over a squared. And you're done.